Hello, and thank you for joining us today. I am José Pereira from INESC TEC and the University of UMinho, and I'm here to introduce the AIDA webinar series, a joint initiative of the AIDA project and the CMU Portugal Program. These webinars will gather experts from academia and industry involved in the AIDA project and will focus on improving 5G risk management. Today, we'll have two speakers, Carlos Martins and Pedro Fidalgo, from the project's leading partner, Mobileum, to talk about integrated risk management on 5G. Carlos Martins is the head of engineering at Mobileum. He's an experienced hands-on leader with a track record of developing innovative solutions leveraging machine learning, artificial intelligence, big data, and cloud technologies. He is responsible for the development of solutions in various areas, including fraud, revenue assurance, and analytics for carriers and large enterprises. Pedro Fidalgo is the Director of Risk Management, Security and Signaling, also at Mobileum. He is working on product management and delivery in telecom and computer software. Pedro Fidalgo is also a researcher in 5G, complex networks and systems in the areas of fraud and abnormal behavior detection. We have reserved some minutes at the end of this session to answer your questions and for general discussion. So please use the chat to share your questions and comments during the presentation. We'll have the opportunity to answer them and discuss them at the end. I now ask Carlos and Pedro to share their screen to start the presentation. So the screen is yours.
Thank you for the introduction, and thank you everyone for joining today. We will start with an overview by Pedro, and then we will jump to some specifics around the software and what we are doing in AIDA to work with the demand and the challenges that we have with 5G. And then at the end of the presentation, we will review the use cases that we are using to test everything that we have been researching and developing in the AIDA project. So to start with, I will welcome Pedro and also share with him the control of the presentation. So just a moment. Okay, Pedro, can you please test if you can use it?
Good morning, good afternoon, or good night to everyone. Let me try. Give me 1 second. Yes, I do have control. So we're going to start a little bit with the perspective of how is 5G today, and we have 3 different scenarios. The first one where there is already a 5G network and the users have a 5G phone. Then the other scenario is where you have a 5G network, but the majority of the users still have a 4G phone. And the last one where the users have a 5G phone, but still they have 4G plans. And as you can see in the graph in here, the highest chunk right now goes to the last scenario, where users have a 5G network, but they do not have a 5G subscription. So 5G is a lot disruptive concerning the previous generations of mobile networks, specifically because it allows 3 different types of business, which mostly rely on, and this is vertical kind of business, rely on the massive deployment or in the latency, very low latency or speed. This will allow multiple different business players to get into this network, different business models, which will be charged differently. So from gaming, from streaming, from virtual reality, most of these scenarios will require different capabilities in the network, so they will be using different charging capabilities. Another thing that it's quite interesting in 5G, it allows network slicing in order to allow these kind of verticals to be created. And these network slices, they can be dynamic. They can be dynamic in multiple ways. We can have a partner which is able to create on demand different types of slices. This can use a template or a more dedicated kind of slice, which will imply that the majority of the tools that we use today, mostly for BSS and OSS, they change in a way that they can comply with the dynamic that is associated to the 5G networks. This means also that it will require us as a risk management to actually monitor in real time what is happening in the network. Are we creating new slices? What are the SLAs for those slices? Are the users that are being allocated to those slices the correct users? Are we providing the correct SLA? So there is a lot of new things that we need to monitor in real time in the perspective of risk management and fraud. And to give you one example, for instance, for the 3 vertical cases that we have, if you go for the e-medicine, if you look at the variables, the low latency and reliability, it's the core principle. So this would create different type of business plans and charging models specifically for this kind of tenant. But if you go for the smart meters, they will have mostly a different perspective on the value of these variables. So latency is not a concern, but energy efficiency, it is a concern. So this would probably most likely be the type of charging that would be applied on this plan. And last, if you go for connected cars, which is the tendency that you've seen here, guarantee the quality of service, it is what they require mostly in this tenant. This means that there are multiple different business cases, all of them requiring different levels of service and being charged in different way. This means that in this perspective, we are going to monitor the network and at multiple different layers. This means that we need to ensure whenever there is a new slice, we need to ensure that at the network level, the resources that were allocated, they were correct. Network operations also, and the business operations, all the BSS and OSS resources that needed to be used in order to assure those slices, it is created. So the new system needs to monitor the full closed loop of assurance. Traditional in the previous networks, in the previous generations, they were ETL based. We relied in the layer between the network and the service layer, and we would monitor revenue assurance and fraud at this level. When it comes to 5G, 5G network, it is important to say that there is a new concept. We need to integrate with many different services in the network, from the network functions, with the digital systems, with the different partners. So we need to be based in APIs, and quite right now, TMForum with open APIs is one of our best approaches to actually connect our revenue assurance and fraud management systems to all the different systems in the network, and not only to automate, but to react in real time and monitor in real time this network. This is very important because in 5G, as you can see, there is an automation should reduce costs, labor costs by 90%, reduce total time of any process from start to resolution by 90% as well, and the target to improve by 90% as well the time required to introduce a new service. It is important also to know that in a 5G network, we are no longer dependent on silos. It is quite important, and this is the main importance of APIs. We need to access data in an effective way. in multiple different types of data that cannot be dependent on a manufacturer, cannot be dependent on a provider. Then it needs to be APIs for us to have access to the data in real time. This will allow us to have a continuous query of processing of these event sources, having the streaming analytics engines to look at this data as they are processed, apply the rules, and have all the outputs that is required in a 5G network, which is the automated actions. So whenever something is not in accordance to what is expected, we have the capability to automate it and act in the network, generate alert, monitor the business process, and have continuous analytics over the data that is created. I hand it over now for my colleague, Carlos.
Okay, thank you, Pedro, for this great introduction. So if we think on what is the demand of 5G, Pedro told a bit about the bandwidth expectations and also this relentless pursuit of the low latency. If we think that a surgical event or a driving car needs to make a decision in a per millisecond approach, so there will be this challenge of a low latency. But before we go there and why this is important, let me talk a bit about what is the service-based architecture and why it is important in 5G. So for the ones that are familiar with telecom, telecom is not now on the verge of a transformation. It started with a traditional approach with a classic network appliance. That what this means is that there was proprietary hardware and software. So for network functions like HLR, PCRF, or IMS, what it means it was that each vendor would be providing the hardware, but also the software. And at the end, things wouldn't interact with each other. They were doing just their own purpose, but without reusability and without any sharing of capabilities. Then there was an upgrade to a virtual network function. What it meant was that in terms of hardware, it no longer had to be this proprietary hardware. It changed to a way that there were virtual appliances. So the hardware could be shared among the different software vendors. But in fact, there was this network function that was not really interchangeable or interconnectable between the others. Now, we are moving towards a service-based architecture. And if we think on how the industry of software is also moving, it is moving to a microservices approach and also into a cloud-native approach. So this means that we have a service-oriented architecture. It means that the different services in terms of network, they are virtual, but in a way that they are attended by a cloud-native approach. And at the same time, one good thing, and we will discuss that later, is that each one of these services does only one small thing that allow you to combine the multiple small things into a system. That means that it is no longer just one strong monolith that is serving it all, but small pieces from different vendors that can be connected, that can be combined in a way that at the end of the day, it is the business side that will drive the use cases and that will drive the needed agility. So if you paid attention to what Pedro was showing from the slices of the network, it means that each one of that slices will have very different demands. And so the combination to attend these different slices demands means that each one of these small containers that we see here will do a combination of a function, and those functions in the end will provide the benefit of an application. So this is a major shift in the way that the operators are attending and are building their own use cases. Of course, that when we talk about 5G, it's impossible that we don't talk about the challenges in terms of engineering. So there is a lot to attend on the hardware side also. That won't be the focus today on where we are. And if we think on risk management, we are not that focused on how ultra reliable and low latency are the radio networks. Our scope is always to make sure that every single function of the system is doing what it is supposed accordingly, and that there are no specific fraud attempts in each one of these functions. But still, from a 5G perspective, we know that, and it is something that AIDA is also taking a look at, it's when we have this combination and this service mesh, every new function that we put on the system, we need to ensure that there is a strong security and authentication framework, a cloud computing approach, the software-defined networks that would allow to do this combination into a final application, and orchestration that allows to intercall all these functions in a way that this application works as a whole. One important point that is quite exciting for every one of us, it is the multi-access edge computing. So if we think on the demand of data and the use cases like a car or that surgery that we were seeing, this will produce terabytes and terabytes of information per minute or per second in some cases. That means that the idea on transferring all this data from the devices until the cloud, what it means is that sometimes the scenarios that you are doing detections will be already too late. So having part of the 5G standard, the multi-access edge computing, and having edge locations that would allow to do a regional processing instead of sending all the data to cloud also leverages a lot of new use cases, and in the risk area even more. If we think on fraud, for instance, having the ability to detect a fraud in a regional area before it becomes spread into a national or continental scenario, it is quite exciting, and that's why we are also looking from an engineering perspective to the edge processing. So a bit of a summary what I described from this transformation. So there was this solo network with different functions that were too tightly coupled. Then there was this change into decoupling into a virtual network approach with virtualization between the network and, of course, the hardware. But now we are in an area that we are already looking on the 5G to the network functions, which each one of the functions will be a piece of the puzzle. So what if Pedro Fidalgo talk about optimization, the 90% optimization? Why is that? I'm sure that all of you were part of these auctions on buying the 5G spectrum. And the values were quite immense. So we were talking about hundreds of millions in order to buy the 5G spectrum. So the operators are becoming more and more part of the serving on the network side. And for them to make the necessary revenue to have a return of investment of what they invested already, they really need to shift to a lean approach in terms of cloud, of network. To do that, they need to be following these cloud native functions and approach, so that they can spend less money in integrations and less money in hardware. That is key for their return of investment. So 5G as a cloud native application is, if we look at what was presented and why this is important. So when we talk about an application, it is clearly a 5G network slice or a mobility service. The good thing is that nowadays with a 5G and with this dynamic approach, an operator can assemble this with just a set of clicks, no longer having a lot of demand to the network engineers or to the software engineers. They can do that on their own. Where there is already a set of microservices that they can use in order to leverage what's needed for that application. This is really a major shift in terms of agility. One example that we really like to use on the network slices is when we have a major event. So let's say that there is a concert and there's a concentration of thousands or a lot of thousands in one place. and most of that users will be streaming for sure what they are seeing on that concert. So with the 5G, it's quite easy for an operator to spare a network slice on that specific location. And if we think also on an edge processing approach, you can even do the analytics already on the edge of that regional area where the concert is occurring. So this is quite interesting. The way that it uses the network functions through the cloud infrastructure, container as a service, and platform as a service is evolving. There's a lot of opportunity, and there are exciting startups appearing also on the platform as a service. And if you notice, there is currently this demand for a no-code platform approach that is quite important for a business user, someone from the business side, to quickly build this application without having to know how to code, but just drag and drop a set of functions that would allow them to build a new business scenario. So when we talk about the orchestration and cloud native, it is impossible not to talk about Kubernetes. Kubernetes is being adopted as the orchestrator in all the network functions, but also on the business side. We know that Kubernetes is here for a long time. Now it is becoming more mainstream. The main message is that it's no longer just for the software stack, but also on the network stack. But like any new technology for an operator, this is also there is also a challenge. This is a new technology stack. It will be pushing a set of immature tools that are growing on the microservices ecosystem. One is for sure Istio, that we will talk shortly in terms of service mesh. And of course, there's a set of new skills, and that while in the past everyone was focused on the telecom area, mostly on the telecommunications and the hardware, now we are shifting more to a software side. So there is this need to attend new skills and to know more about cloud native computing, low-code platforms, and of course Kubernetes. Well, but the solutions are here. There's already a lot of solutions, and RAID is one of it for the low-code, no-code, and also to build out-of-the-box solutions for the risk management when it comes to business assurance and fraud management. So when we talk in each one of these network functions, in fact, when we look at it, it looks like just one single box and just one services. It's not the case. So each network function is a decomposition of even smaller network function implementations. So if we think that each network function will be working as one big piece of the puzzle to be orchestrated, it easily relies on ensuring that there is a service mesh. Okay, so that it is the combination of the different network functions as microservices that will make the global network function, and that would allow to build an application. With this, there's new API gateways, there's a lot of interconnection between the different microservices. It can be REST, it can be gRCP, and there's a lot of standards in the industry that are being adopted, but mostly REST and gRPC. One of the things that we are also exploring on AIDA, it's the use of Istio. What Istio does is to ensure that there is a sidecar in each one of the services, that is the Envoy proxy, but also ensures that from a rollout perspective, you can be launching different microservices and different smaller cloud native functions in a way that you can have blue-green deployments, for instance. One important thing is for you to roll out a version 2 of a microservice while running a version 1, and they can run both in parallel, and where the operator will be able to say, okay, 95% of my traffic will use version 1 and 5% will use version 2 without doing any network disruption. So this is also something that we are using in AIDA, but the good thing is that even the telecom operators are using it in the network side. So I introduced already a bit the multi-access edge computing. When we think on mission critical and low latency applications, it is impossible that we don't talk about the 5G edge, okay? And we have also on AIDA one particular use case related with fraud that could not be possible to solve without this edge approach because of the volume of data and the need to be in a low latency approach. If we think on, and if we look at the ETSI specification, and when we talk about the edge architecture, we could say that a device is also an edge element, but in fact, as part of our risk management and AIDA scope, we won't be installing absolutely nothing on the consumer's end side. Okay, that is very important. But from the edge on, from the network to the telco network to the data center to the cloud, this is all part of the AIDA scope. This is where we'll be installing our own software and where it will have to comply with each one of the requirements when it comes to both network and processing. As you can imagine, installing on a network edge or an on-premise edge won't have the computational power that we have on a data center or on a cloud provider. So even the pieces of the software that are being designed in order to do, for instance, a machine learning inference have to be reduced in terms of the hardware it consumes, and also attending the demand in terms of the latency that is expected when we are processing this kind of data. So data is the new oil, everyone knows that, but the way that we are with 5G handling data, it's changing a lot, okay? There's a data shift from a network-aware application design to an application-centric network provisioning. So, like I said, the business will be more agile. The business side will be able to design new applications on the fly. So it's no longer attached just to basic network functions. It means that the orientation of data will be more than ever cross-domain, that we will be working mostly with streamed data. The data aggregation and analysis is full decoupled. So if we think on the batch approach that was done in the past, that you were ingesting data and from hour to hour or day to day you were doing aggregations, that is no longer possible because you need the aggregations on the fly. And because you are building applications on the fly, you are also building new schemas that the applications need to comply with and to be able to do a schema on read instead of a contract that was previously signed as the schema on write. Machine learning, of course, it's here more than ever, and even to comply with those aggressive 90% optimization in everyone's time, and because time is money, more automation, more artificial intelligence will be needed in order to comply with the analysis and the amount of data that is being addressed. Data. And because AI and ML don't live with data, of course, that the data governance will be towards a data lake or more than ever a lake house. And a data lake, it's not enough. So a lake house where the AI is reading the data from. And so we can no longer support silo data because AI wouldn't be able to comply and machine learning to comply with silo data that is from a disparate set of data sources. So what does this mean is that our applications are no longer just a deployment on a central cloud like we did for the last 20 years. It means that there is more than ever a serverless orientation. So that means that there is a full decouple on what is the software running underneath it. And the hardware, it's no longer something that you should pay attention to because it's a serverless approach. And one important aspect, it's every time that we deploy an application on a central cloud, we will be also deploying it on an edge architecture. So this makes the architecture a bit more complex, but already with some interesting use cases that will show why the edge architecture and why 5G needs this edge architecture in order for us to have success on the fraud management area and also on the business assurance. And that's what we are doing in AIDA, is to make sure that the edge it's quite studied and quite explored, but without never compromising the need for an analyst to take a look of what was going on, what is the machine learning doing, what is the prediction, how are we evolving our machine learning and artificial intelligence in a way that we can comply with the amount of data and of course with the promise of a faster network, but more than ever a safer network. So Pedro, it's up to you now.
Thank you, Carlos. So we're going to have 4 different areas concerning risk management in 5G. And the first one is it concerns the provisioning, the dynamic provisioning that we're going to have, the usage, which will be dynamic as well. A couple of examples were provided by Carlos concerning streaming, the necessity of having some network resources for a short period of time. And we have to ensure that the provisioning and the deprovisioning of those resources, they are in accordance. We don't have resources in the network that are not being used. Whenever you increase the capacity, we are going to charge for it. Whenever you decrease, we are able to reduce the network resources allocated to that specific event or use case. So a lot of the necessity that we are going to have in 5G is going to be in controlling the dynamic of the usage and the provisioning, and mostly the SLA or the latency or the kind of business model that it applies to you. The next one, I'm having some lag in here. Carlos, I will ask you to please, okay, thank you. So the next one is really for billing validation. With the if you require resources just for a small amount of time, if they shift in the amount of networks that they use, if they require different capabilities from the network, we need to have the capability to adapt all the billing validation once again to the dynamics associated to 5G and the use cases of 5G. This is especially relevant when you start to talk about IoT, which requires a lot of different devices in the network, and it will produce a lot of data, and this data will be dynamic in its billing. So very important to have those capabilities in billing validation. Sorry, okay, double click. So in terms of margin, we have now the capability to go from back to back, which is to ensure that whatever service you provide to your customer, we are able to monitor from the resources that were allocated in the network, but also in terms of the profitability that it provided. Namely, if you are using in a particular use case for a particular customer with the amount of resources and the quality of service that you provide, if this service will be profitable. So something that is quite important to have it in real time and the analytics to do it. Last, in terms of fraud management, in terms of fraud, it is interesting that it's even GSMA tells right now, we don't know what to expect in 5G. So this is something that is quite important because we need to monitor not only the fraud types that we know that exist today, but also the ones that will become relevant later on, especially when you have a disruptive network has 5G, where it becomes a business network. It is quite important to have abnormal behavior detection, ensure that you don't have any sort of hacking in the whole chain, because if one device is hacked or if one partner is hacked, it can affect the whole network. Ensure that the slices, some of these slices are really important, especially if you go to e-medicine. You can often have, if you have some sort of abuse or some sort of security issue on those slices, the impact will be high. So this is quite important for us. And we can see the slicing has one of our main aspects on how to deal with the 5G risk management. We can have multiple different verticals. So we have the 3 verticals that we see it in here. We can have multiple different types of customers. These customers will use the same resources, the same network elements. They will have different needs. But at some point, when we start to have a high number of customers, we will realize that there are some overlapping when they use. So most likely the type of controls that we apply to a customer, we most likely can apply to another customer. And this is where we expect from the artificial intelligence and machine learning models to actually understand that you have different slices, all of them with different customers, but looking at them, there are some overlapping in terms of controls. So maybe what applies to a slice for a specific customer, it might apply the same set of controls to another one. So this is something that it will be run in our system in order to find these specific controls that will enable the automation of fraud rules specific for the customers and slices. Has a wrap-up in terms of a system to control the 5G risk management. We need to scale to a point where we can, as the customer grows in terms of size, we need to grow as well. We are going to have multiple edges. These edges will have their own model that will learn. It is necessary to gather all this information into just one unique model. So the importance for the machine learning, federated machine learning, be resilient to intrusion and tapping. We need to trust all the edges and all the components in the network. And last, data privacy and confidentiality. Make sure that the data is not exposed, the data is secured between all the different partners, and it will not be attacked in a way that can be processed by external resources. And I think this concludes our presentation.
Thank you, Pedro and Carlos. So let me just stop your sharing. So we now have some time for the discussion. I remind you that you can send your comments if you want to share comments with Pedro and Carlos and the rest of the audience. And also you can pose your questions. Actually, I would like to start by making a question. So you have explained how 5G changes a lot in terms of engineering. You've also explained how it changed in terms of business. So there are new opportunities for fraud and for new attacks. And my question is, since this technology is being phased in, what is your expectation in terms of timelines for these different scenarios to materialize, both in terms of technological deployments and in terms of these new risks?
Yeah, so from my point of view, what we are seeing is that 5G, it's still, we talk a lot about 5G in the last 2 years, but the massive adoption in terms of a consumer base is not there yet. So if we can use the example in Portugal, what it means is that people right now, they are using 5G if they have a device that can take advantage of that. But in fact, this is just a 2-month experience, and then there will be a different subscription for people to pay to use 5G. I don't think that while those subscription fees will be part of the deals, that would allow the consumers to really take advantage of 5G, that from a consumer-based perspective. So the use cases that in terms of fraud that we face nowadays on 4G and the other technologies, it will take for sure 2 to 3 years more until we have a similar effect on the consumer base. Now, where I see that the 5G will ramp up faster, it's on the enterprise side. Okay, if we think that we are on the industry 4.0, one of the things that we are seeing in the industry 4.0, I can give you a concrete example like agriculture. If you go nowadays to a modern vineyard, you will see drones, you will see sensors for humidity, you will see sensors everywhere. And the combination of all this data, it will be achieved, and making decisions on top of that, it will only be possible with the 5G approach. And so the enterprise will, for the first time in this industry of telecom, enterprise will be ahead of the consumer based. So if we think on this approach, for sure what we will have is fraud scenarios that are coming from the enterprise 4.0 in a 1 to 2 years landscape, and on the consumer side from the 2 to 3 years landscape.
Okay, thank you. So another question that I have, and this is my here is my researcher curiosity that is ticking me. So you have described all these changes in terms of the environment in which you'll have to run the machine learning systems. So the multi-access edge and the slicing, and all of these leads to multi-tenancy. So you have all these infrastructures which have bits that are used by different actors. What do you think are the biggest challenges here for machine learning that will allow you to have something that is effective and at the same time respectful of privacy and the security of different participants?
Yeah, that is a very good question. I think that from a machine learning perspective, there's this privacy part that in telecom, it is really a challenge, because the majority of the relevant features of the data, they include private information. Okay. So to make sure that we have effective models, there's also the need to make sure that data is transported in a safe way, but at the same time, if it is encrypted or obfuscated somehow, it cannot lose the main features and some particularities of the data. So that is the number one challenge.
But I have one final question. So you have mentioned the importance of the open standards in telecom and in all these infrastructures, but I can also see that there is an increased usage of open source. And my question is, given the increased speed at which all of this is changing and evolving, what's your opinion on the relative merits of these two things? The open standards that where a process takes some time, and the open source that probably can evolve faster but doesn't have the same formality of process as the open standards.
I don't know, Pedro, if you want to answer.
So it's your opinion on that. What do you think is the relative importance of those two approaches to this?
Yeah, I can talk a little bit on the perspective of the open standards and the open APIs when it comes to 5G. So it is a great benefit to, and obviously it's something that it will decrease the complexity that we have today. It will, and if the community, so let's put it this way, you don't need to be a telecom engineer to actually start to design new functionalities, because it is open, it is using standards, and this is something that 5G it is producing. It is producing APIs, it is producing standards that the majority of the community will understand. There will be open knowledge, there will be open source. Doesn't have to be no longer something that someone that worked in a previous network or in some equipment provider decided to join an open source project, and all of a sudden you have a new technology that is being explored. So this is in one way, but also in the perspective of risk, we are just exposing the knowledge to everyone. So you have open source, you have open APIs. You no longer need to be a telecom engineer or a specialist in many different fields to actually understand the world of 5G. So the types of fraud that we will expect also in the future will definitely increase based on these open standards and APIs, and the knowledge to work with a 5G no longer be a specialized kind of individual.
Okay, thank you. That's a very interesting perspective, the risk aspect of this. So as we don't have questions from the audience, it's time to close. So thank you for your participation. Thanks again to Carlos and Pedro. I only have to ask you to stay tuned and don't miss our next webinar, which is on the subject of the impact of edge computing and 5G for telcos. It will take place on February 11th, 2022, with Ricardo Vilaça, my colleague from INESC TEC and University of Minho, and Bruno Souza from the University of Coimbra. So see you soon and bye.